Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, right? And here we are going to find out the Laplace transform of this delta function, that is delta of minus pi t plus 1, right? So we'll find out the Laplace transform of this delta function using an important property of delta function. So let us first define the Laplace transform of some function, say f of t, right? So the Laplace transform of the function f of t is given by this integral, that is 0 to infinity. We have e raised to minus s times t, and here we have f of t dt, right? So here we can take this function as f of t. So the Laplace transform of this delta function is now given by this integral 0 to infinity e raised to minus st, and f of t may be replaced by this delta function, that is delta of minus pi t plus 1, and here we have dt, right? So now we have to find out the value of this integral using the definition and property of Dirac delta function. So now we have an important property of delta function, that is delta of ax is given by 1 over the absolute value of a, and here we have delta of x, right? And here a is not equal to 0. So delta of ax is given by 1 over absolute value of a times delta of x, right? So now we can also write a modified version of this property, that is delta of, say, ax minus b can also be written as delta of, here we can take a common between ax and b, so we have x minus b over a. So now we can apply this property to this expression. So we have here a, so we can now write 1 over absolute value of a and delta of x minus b over a, right? So here we have delta of minus pi t plus 1, and will apply this property to this delta function. So now delta of minus pi t plus 1 can be written as delta, and here we can take minus pi common between minus pi t plus 1, right? So here we have t, and then we have a negative sign here because negative and negative becomes here positive, and we have 1 over pi, right? So now this delta function is similar to this one, and here the value of a is minus pi, right? So applying this property, we have 1 over mod of minus pi, and then we have delta of t minus 1 over pi, right? And mod of minus pi is equal to simply pi, so we have 1 over pi delta of t minus 1 over pi. So now replacing delta of minus pi t plus 1 by this expression over here, the Laplace transform of delta function is now given by 0 to infinity e raised to minus st, and here we have 1 over pi and delta of t minus 1 over pi, and here we have dt, right? And 1 over pi is a constant, we can take it outside the integral. We have 0 to infinity e raised to minus st, and we have delta of t minus 1 over pi, and here we have dt. So now here we can see that we have this function e raised to minus st, and here we have delta of t minus 1 over pi. So we can evaluate this integral by using the definition of delta function, that is minus infinity to infinity. We have, say, f of x, and here we have delta of x minus a dx. Then the value of this integral is given by the value of the function f of x at this point, that is a, right? So we have f of a. So here we have this function, and the value of a is given by 1 over pi, right? So the value of this integral is equal to the value of this function, that is e raised to minus st at this point, that is t is equal to 1 over pi, right? Because 1 over pi, it belongs to this interval, that is the limits, that is 0 to infinity, right? So now we have 1 over pi and e raised to minus s times t. Taking t is equal to 1 over pi, here we have minus s times 1 over pi, right? So this is 1 over pi, and taking this term to the denominator, we have e raised to positive s over pi, right? So this is the required Laplace transform of this delta function.